So what you see here is the results that I have from an experiment. I have different masses of water that I heat, and I'm recording the final temperature. The initial temperature is 15 degrees Celsius. The power of my kettle is 2000 watts, and I'm heating for 30 seconds. So these are the results that I'm getting. Now, I want to actually plot whatever makes sense according to the formulae. So here I have Q equals mc delta T, the thermal energy Q equals the mass of the water in kilograms, times the specific heat capacity, times the change in temperature. And the thermal energy transferred is also the power times the time, the power in watts times the time in seconds. So I can equate those two and get Pt equals mc delta T. If I rearrange this, I get delta T, the change in temperature, is equal to the power times the time in seconds, divided by mc, the mass times the specific heat capacity. So I can write this as delta T equals, and then here in the second part you see I get power times time over the specific heat capacity times 1 over m. I'm just writing this in a weird way, and the idea is that delta T is basically proportional to 1 over m. So what I want to calculate now is 1 over m. So to do this, I type in equals 1 over. Now the mass is here, and the mass is currently in grams. I want it in 1 over m to be in 1 over kilograms. So I need to do brackets open A7, that's my cell, or if you don't want to type it in, you can just click on here and it comes up automatically as A7 and divided by 1000. And there we go, there is my 5. 1 over 0.2 is 5. Double check often, well, sometimes you make or the spreadsheet makes mistakes, like if you don't put in the brackets here, for example, and then afterwards you wonder what on earth it has calculated for you. If you rearrange this, you could also just write 1000 divided by A7, this value here, and there's my same result. That's just mathematically the same operation. Now I have done this for the first cell here. I want to do it for the next 6 as well. So I'm going to go into the bottom right corner of this cell, A25, and drag it down by 1, 2, 3, 4, 5, 6 more cells, and I get these results. So this is 1 over m calculated for each one of these. If you check, I get for the third but last, for 1000 grams, 1 over 1 kilogram of 1 is of course 1, so that makes sense. Now my average final temperature, here I just put in equals average, and then you take the values, highlight them here, and enter, and then you just go into the bottom right corner, drag it down, and then you want to actually find the change in temperature. That was the final temperature minus the 15 degrees. You enter minus 15 and drag it down again, and there your calculation's done. This is fantastic as long as you know what you're doing. It's super fast and very reliable. It takes you way less time than using a calculator, and the calculator is of course a lot more prone to errors as well. Now we come to the uncertainties. For this, you want here to have the uncertainties in, and delta, confusingly, is both used for the uncertainty and for the change in. So delta of 1 over m is in 1 over kilograms is the uncertainty in this. Now the uncertainty of 1 over m is the uncertainty, and this you will actually get your head around probably only in August when you look at how uncertainties are done in the IB. I'll just show you the calculation here now. Don't worry if you don't fully understand this at this stage. It's a bit too much for this one session, okay? So therefore I'll show you, but I'm not going to explain. You'll take the uncertainty, the relative uncertainty that you have here, and that was 2 grams out of whatever here it shows 2 grams out of 200 for the first one, and you multiply this value by this value. So the relative uncertainty, which is the absolute uncertainty of 2 grams divided by the value, in this case of 200 grams, and multiply that by 1 over m. So if I do that, I get 0.05, something very small. And then I'm going to extend this here till the very end. Important is, uncertainties in the IB are given to one significant figure most of the time. I want to prettify this and make sure that I only have one significant figure. If I shorten this one here, I'll be fine. Now, the tricky bit is the IB also requires you to have the same number of decimal places in your uncertainty and in your data. So here I'm fine. I have 2 decimal places here, and I have the same in my uncertainty in 1 over m. Here, now, I also am fine because I have 3 decimal places and 3 decimal places here. So all sorted as far as these first 2 columns are concerned. Now I want the uncertainty, and I'll write it in a funny way, of the change in temperature. And don't forget the unit. You have degrees Celsius here. On the Mac, by the way, the keyboard shortcut is Alt-Shift-8 for the degrees sign, in case you're wondering, and Alt-J for the delta sign. So here I do the following. I need to calculate half of the range. Half of the range means I put in equals the maximum value of these values minus the minimum value of these again, and divide that by 2, half the range. So there we go. And I apply these to all the 3 rows that I have. And now I need to make sure that my number of decimal places match. Here, all of them are to one significant figure. That is good. That's what I need to pay attention to first. And now I need to make sure that the decimal places match, and that is the case. I am sorted. All good. So now I'm ready to go and put all this data into Logger Pro and take it one step further. So that's the calculation of uncertainties which you need for plotting your error bars in Logger Pro. You have just been absolutely amazing. You haven't interrupted me a single time. Thank you for paying full attention to all my detailed explanations. Have a wonderful day.